Alright, ladies and gents, sorry I couldn't be there today to help you through this, try not to be disappointed, but I'm going to go ahead and make this short little video for you to help you go over this study guide and figure out how to answer the serious question at the end of the CER, which is really going to help you for next week, Tuesday, the 21st on the exam, which is going to look very similar to this, just different elements. So the first portion is this little data chart here. It's actually pretty easy to fill in. Most of this information you already know how to get. We've already tested you on it. The new things are going to be this name of ion, cation or anion, and then the ionic charge. So let's go ahead and pull out our periodic table here, and I'm going to do lithium and nitrogen for you. You'll do fluorine and neon on your own. Here's lithium. It's in group 1A, so we're going to say group 1A. Nitrogen, it's in group 5A, so you can say group 5A. And again, you'll do those two on your own. Number of valence electrons. Remember that the number of valence electrons is determined by the number with the letter A next to it. Lithium's in group 1A, so it has one valence electron. Nitrogen is in group 5A, so it has 5 valence electrons. Ionic charge. This is where you have to ask yourself, is it going to gain or lose electrons? Lithium is a metal, and we all know that metals like to lose their electrons. How many electrons are they going to lose? They're going to lose all of their valence electrons. Now, lithium has one valence electron, so it loses all valence electrons. And you have to remember that electrons are negative, and if you're losing negativity, you're going to become more positive. How many negative things did it lose? It lost one negative thing, so it has a +1 charge. Nitrogen is in the non-metal portion of the periodic table, and you have to remember non-metals like to gain their electrons, and they're going to gain however many number they need to get to 8. Nitrogen already has 5. How many does it need to get to 8? It needs to gain 3 electrons to get to 8. So if you're gaining more negativity because electrons are negative, you're going to become more negative. How many negative things did nitrogen gain? It gained 3 negative things to get to that 8, so it's going to have a -3 charge. Name of ion, cation or anion. Remember, cations are the positive ones, and the anions are the negative ones. So the ionic charge on this is positive, so this is your cation. The charge on this is negative, so this is your anion, and the camera will focus in just a moment. There we are. Period number. Remember, periods are the numbers running along this side of the periodic table. Okay, lithium is in period 2. And lo and behold, so is neon. It's also in period 2. Number of energy levels. Guess what? The number of energy levels is the same as the period number, ladies and gents. It is literally that easy. So it's 2 and 2. If it's in period 2, it's got 2 energy levels, or 2 rings. If it's in period 3, it's got 3 energy levels, or 3 rings. Okay, now, it's been a while since we've done Bohr models. It's the one with the P equals N equals, and then how many dots do you put into the rings, and how many rings do you use, so forth and so on. Well, for lithium, remember how to figure out the number of protons. It's the atomic number, okay? 3. So that means there are 3 protons here. That also means it has 3 total electrons, okay? 3 total electrons. One of the electrons is going to appear in the very last energy level, which is what the valence ones are. But we'll get to that in just a minute. Who remembers here how to calculate the number of neutrons? Remember, the number of neutrons is the atomic mass rounded to the nearest whole number, subtract the atomic number. So what's 6.94 rounded to the nearest whole number? 7. And how many protons, or what is the atomic number of lithium? It's 3. So you've got 7 minus 3, which means it has a total of 4 neutrons. N equals 4. Alright. If it has 3 total protons, it has to have 3 total electrons. Okay, and we are going to place them in the rings. Now, these models give you more rings than you need, so how many rings does lithium actually need, or how many energy levels does lithium need? We calculated that already. It only needs 2. Okay, how many can the first energy level hold? It can only hold 2. The second energy level can hold a maximum of 8. The third can hold a maximum of 8, and it's 8 all the way down. Keep going forever. All right. So for my first ring, I need 3 total electrons. Okay, so I've got 3 electrons total. I'm going to put 2 in the first ring because that's the max I can put there. You have to fill 1 ring before you can move out to the next. I've used 2. I need 1 more. So that 1 more is going to go into the next ring, which is the second energy level, and that's the total. That's the maximum amount of energy levels that lithium can have. And there's only 1 in the very last one, which corresponds to 1 valence electron. What is the Lewis dot structure for the neutral atom? Remember, the Lewis dot structures show the element symbol and the valence electrons only. Well, the symbol for lithium is Li. How many valence electrons does it have? It only has 1, so you only need 1 dot. What is the Lewis dot structure of the ion? Well, remember, when it forms an ion, lithium, it's going to form a positive 1 charge because it loses its electron. So we need to redraw the element symbol with no dots in it this time. In fact, every metal's ionic structure for the Lewis dot, if it's a metal, it has no dots around it. It only has brackets. And then you put the charge with it. Okay. Let's do nitrogen next. Nitrogen has 7 protons because it's got its atomic number is 7. Its neutrons, well, you take its atomic mass, 14.01, round it to the nearest whole number, which is 14. Subtract 7. 7 minus 14 is 14 minus 7 is 7, which means n is going to also equal 7. If P is 7, that means it has 7 total electrons. 5 of those electrons need to end up in the last energy level. And I can only use 2 rings for nitrogen. So 2 of those electrons are going to go in the first ring. That fills that ring because the first can only have 2. And that means I need 5 more in the second ring. 1, 2, 3, 4, 5. And that's it. Lewis dot structure for the neutral atom. Before any electrons are gained or lost, you start with the element symbol. And how many valence electrons does it have? 5. But you also knew that from right here. And remember with Lewis dots, you separate them out before you double them up. So 1, 2, 3, 4, and 5. You have already determined that nitrogen likes to gain electrons. It doesn't gain any number it needs to get to 8. Well, you said that it already needed to gain 3 to get to 8, so that means it's going to have 8 dots around it. In fact, if it's a non-metal, with the exception of helium, it's always going to have 8 dots around it if it's a non-metal. Excuse me. And then you need to include the charge, which is -3. You should be able to now do these 2 on your own. And then the CER, based on your questions 1 and 2, which elements Li, N, F, or Ne is most likely to react or bond with, which of these 2 elements are most likely to bond? So the first thing that was listed was Li, F, or Ne. So we need to choose the 2 that are most likely to bond. And I can tell you right now, it is going to be the metal and the non-metal. I gave you a metal, this is a nonmetal, this is a nonmetal, and then this is a nonmetal. Which two are most likely to bond? Well, it's going to be definitely this one, because that's the metal, and then it's going to be one of these nonmetals here, but which nonmetal do you choose? You choose the most reactive one. That's when you have to come back to this chart, okay? Neon is in group 8A. It doesn't react, so we're not going to choose that one. F is in group 7, very, very reactive, so we might choose that one. And N is in group 5, not very reactive, so I'm not going to choose that one because it's not as reactive. So that means Li and F are most likely going to bond together. You need to state that clearly in one sentence in your CER. Discuss how electrostatic attractions leads to ionic bonding. Electrostatic attractions mean the positive interacts with the negative. This is the negative, this is the positive, so that they cancel out. That's the whole point of that. Explain how atomic radius supports this claim. Well, the bigger the atom, the more reactive it is, okay? And atoms get much bigger as they go towards this side of the periodic table, which is where this is. Okay. How does electronegativity support the claim? Well, the atoms get more electronegative as they go this way, and that's why fluorine is very, very negative. Trend for the reactivity? Well, both lithium and fluorine are in very reactive groups. That's why they bond, and so you would say that. So really for this CER, you would need somewhere between 1, 2, 3, 4, 5 to 7 sentences to answer that. Okay. I hope this helps. If you have any questions, don't hesitate to ask me on theremind.com. Good luck, and we'll see you Wednesday next week.